Synopsis. The Flashforge Adventurer 5M Pro is now my preferred printer compared to the Bambu Lab X1C for single filament printing. It costs less than half the price, prints at similar speeds. It is every bit as easy to use, from slicing to changing filament, and even prints over Wi-Fi using Orca Slicer. It is well made, and the toolless nozzle swapping is superior to Bambu Lab. It just works. It prints fast, and it's way less expensive. This is the printer to get. Also, I made a side-mounting filament spool holder for it. It's a nice upgrade. Welcome to Design Prototype Test, the channel where I don't always review 3D printers, but when I do, I frame the entire ecosystem within the bounds of these two printers. On the left here, the EZ3 K9, a $70 printer, which can actually, with a little modification, that's very cheap, like $5, you can get prints that are darn close to the same quality as what you're going to get out of the $1,200 Bambu Lab X1 Carbon. So watch the dedicated video to both of these printers up here if you don't know anything about 3D printers. Like if this is your first video, weirdly, and you found my channel, watch those first. Everything in here is going to have to reference one extreme or the other. So let's talk about the Bambu Lab X1 Carbon, because this being the flagship printer of the I'm going to call it the best brand out there. Everything's going to be compared to this. It's the best, right? Let's put that label on it. Everything in between these printers is a valuable part of the ecosystem to me, and I'm really glad that we have all that diversity to choose from, all of the other brands. And speaking of which, Flashforge. This is a well-known brand. I've never actually had my hands on a Flashforge before. Total oversight on my part, and I'm happy to rectify that right now, because as the spectrum goes, this printer here is going to sit much closer to that printer, and I'm hoping that we have some viable competition, because I just love to see the diversity and to see other companies upping their game to prevent one company from gaining an absolute stranglehold over our hobby. And you know, when companies compete, it's good for you and me. Makes things cheaper, makes things work better. So let's see what Flashforge has to offer. The first thing that I noticed about this printer compared to the Bambu Lab is that the top is not made out of glass. That is polycarbonate, so it's not going to have the sound deadening properties that the glass is going to have over here. And that would be why they have to put all this protective plastic on it in the package to make sure that the beautiful doors don't get scratched during transport. I hate filming with these, shiny printers, because I have to worry about what you guys can see here. Like, hey, look at my pants, look at my shirt. That's not supposed to be in the shot. And I know you autists out there watching this are like trying to get a glimpse of how messy my room is or something like that. Trying to see if I have a password written on a Post-it note in the background that you can see in the reflection. Yeah, the interior has all the foam. It's no more fun watching me unpack this. And this is what comes in the box. The printer, all the extra bits, and a power cord. This time, I didn't mess up, and I ordered the one with US power. All right, we got flush cutters. These are absolutely essential for 3D printing. You're gonna find that you are always cutting your filament with them. You constantly need to be able to clip filament. That's the number one use for them, but I use them to clean up my prints as well, to get support material off. Absolutely essential, totally awesome. This looks like a high quality set of these. I've seen much cheaper come in boxes. That's nice. We've got screwdriver for something. Is it a screwdriver or some other? Yeah, it's a little Phillips or whatever they call that. Japanese spec that looks like a Phillips. We got a couple of Allen wrenches that are very long, and this weird thing right here. What is this poker for? Looks like a fancy T-pin. I don't even know. We got an extra nozzle, so that'll be something useful, and I want to talk about that here in a minute. The nozzle changing in this printer looks pretty cool. This would be the glue stick. Oh, it's not glue stick. This might be similar to that Magic Goo. Flashforge branded 3D printing adhesive. Pretty cool, you guys, that this comes with it. I'm going to guess that that is about a lifetime supply of adhesive, which is, well, that's awesome. That is totally a winner there, not just glue stick. Up until now, this has been the company that I love to hate. I love them. This absolutely is the best. It works so good, and made in the USA, all that stuff. But $50 a bottle, it kills me. Look at how much of this I've gone through, though. I've hardly put a dent in it for all these years that I've been using it. So, yeah, I think it's probably worth the $50. It's like a lifetime supply almost. Anyway, maybe I guess if you get this printer, though, you won't need to spend the $50. So, hey, knock off an extra $50 off the purchase price. I guess you can do the girl math in that regard. We got some lube of some sort. Yeah, this must be for the lead screws. And then this is going to be your filament spool holder. Strike number one that I'm going to give this printer, because the filament spool mounts to the back of the printer. So like you just saw me doing, you got to spin the printer around every time you want to change out the filament. It's so stupid. And this is obviously done. Oh, look at me, so stupid. Trying to put screws in where there's no holes. Yeah, so it's obviously been done like this because they're copying the Bambu Lab X1C. This whole printer really is, I mean, it's not a copycat, but they followed the playbook. So Bambu Lab X1C wrote the playbook, and these guys are following it. But it's not like, I should say it's a copycat, not a clone. So it kills me, you guys. China, like most of China doesn't know how to do anything original. Bambu Lab comes along and does something original. Absolutely, they know how to design like a Western design house. And yeah, of course, like I predicted, we're going to get a bunch of copycats coming from all of the, second tier 3D printer companies. Now, just because they're second tier doesn't mean that they're not adding the value. So it's possible that this printer is still going to be a smarter purchase in the end than the Bambu Lab X1C. But yeah, if you look at this printer, hey look, there's a spool on the back. How dumb is that? Bambu Lab did it, so Flashforge got to copy them. Now, Bambu Lab on this side, Flashforge on this side, so, like I said, it's not an absolute copy, but just because you changed the side which the filament spool is mounted on doesn't mean we can't tell how derivative this printer is of that one. But however, plastic everywhere, plastic on the top, actual glass, metal everywhere. I wonder how much cheaper this one is. I haven't even looked up the price. As of July 6th, 2024, the Bambu Lab X1C comes in at $1,200, whereas the Flashforge Adventurer 5M Pro comes in at $499. So less than half the price, but we can already tell it's more than half the value. Let's hit that power button for the first time. There we go. I hear a fan coming on. That must just be the electronics control board cooling fan, because it's not the hot end fan, and it's definitely not this giant fan. We'll get to the interior here in a second. Oh, ooh, it's musical. Play me a little jingle. Play me the song of your people. This is pretty smart, making sure that it's idiot proof. No dummies. You're gonna break this printer as long as they follow the instructions. Next. Calibration. Abnormal leveling data. Please check. Haha! User error. I need to undo these screws locking the bed for shipment so that we don't have problems. Or those aren't screws, I guess those are Allen key. Hex head. Everyone who owns a Bambu Lab is like, what an idiot. How can he not know about this? Well, the reason I don't know about this is because my Bambu Lab was a refurb that I got. I picked it up at the offices, at the Bambu offices there in Austin, Texas, and it didn't have these installed when I got it. So that's why. This is my first time ever having to undo screws like this in a printer unboxing. Most of the printers that I've ever reviewed have been, what are we calling them? The Mendel style printers with the sliding bed, kind of like this. Look, they've even got yellow arrows telling me where I need to unscrew. There's two more here at the back. The printer is under self-detecting and it may take several minutes. How about, I don't know, self-calibration in progress. Please wait. Flashforge should hire an English speaker to make this sound more natural. It's seeing how quickly it can cool down from 230 to 120 degrees C so that it can set the PID tuning. That's clever. It would be really cool if it told you what it was doing. Calibrating PID settings or something like that. Self-detecting. It's telling me it's going to take 7 minutes and some odd seconds. to do looks like a mesh bed leveling algorithm. It's got touch probing with the nozzle tip. Pretty cool. And now we're doing one of those shaking tests, so we can get the accelerometer data, and it knows, well, in layman's terms, it's calculating the vibration frequency of the printer itself, so that the vibrations don't ring on the surface of your prints. It can calibrate the acceleration and deceleration of the printer to compensate for the natural frequencies that the printer wants to shake at. Please load the filament. Alrighty. I have to say, this is the prettiest filament that I've ever received as a sample in the box. It's got this like purple when the light's not shining on it, blue when the light is shining on it. It's got this like glitter inside of it, some metal flake, whatever you want to call it. Really nice stuff here. Burnt titanium. I mean, I guess it does kind of look like titanium welding. Yeah, okay, I can see that. Yeah, like I said, these snips are quite useful for trimming filament. See that little bend? We don't want that in there. We want it to be nice and straight. And then this feeds into here all the way until we feel it bottom out. See the shadow of it coming through the tube right there? I got my hand back here, so I'm putting pressure on it, and that will allow me to feel if this is working. Oh, we gotta wait for it to preheat. Yep, I feel it being pulled through my fingers here. And there it is, purging. Oh, that's a lot of purge. Loading complete. Clean the filament off the bed. All right, there you go. And then click print. Well, I don't know what I'm printing. There's a cube. Oh, I guess we're gonna test the cube. All right. I don't know what the printer's doing. I'm just along for the ride. Hey, look, it's a 3D printer doing 3D printer things. And quite quickly, I might add. That's speeds that we typically only see on that printer. I do have to say, I like this handle for the flexible bed. And you can just flex your prints right off. The bottom feels kind of smooth, even though there is a texture to this print surface. It's hard to see how smooth it is because of this fancy filament they sent. I wonder if I'm supposed to measure it or something. Nope, now it just says that it's ready for printing, and there's the USB slot to get prints to go on it. So if we click here, we can see the other prints that are included on the printer itself, not on the thumb drive. And I guess there's no thumb drive included in the box, so good thing I have my own. I mean, everybody's got thumb drives these days. There's a Benchy right there. Let's print that. Okay, this is ridiculous. There's nowhere to unload the filament, so I can't pull it back out of there, and there's nowhere to control the movement. If I go to the gears here, all we can do is control X, Y, and Z. There's no controls for the extruder. If we look here on the Bambu Lab, there's the X, Y, and Z, and this, it says extruder. So I've got the thing heated to 200 because I know that's what PLA is. Now even this on the Bambu Lab is ridiculous. I've got to click this thing like 10 times, and then I stick my hand back here and just feel it until it releases. There we go, that released. Oh, the filament actually broke. But normally I would sit back here and I would feel and wait for this to pop out, to pop loose. So that's ridiculous on the Bambu Lab. But it's even worse on this printer. There's absolutely no manual control. If you go to the PLA settings here, it's telling me to literally pull the tube here. So it wants me to do this and then snip this off. And now come back here and feed it through. Load. And once this gets to temperature, 220 degrees, I should feel this tail disappear. See how this reverse Bowden tube is routed through the cable link chain thing? I accidentally pulled the tube back too far and crimped it, so now I'm having a problem feeding the filament through. I couldn't even get the well, I finally got it to poke through, but I really had to push hard, so there's a kink in there somewhere now. I mean, is that user error or is that bad design? Yep, I can feel it loading, so that'll spit out a big tail here in a second. That's just so much waste. My goodness. Why do they think they need to put that much filament through the nozzle? Look at that. Can you stop, printer? Jeez Louise. Alright, Benchy time. So this leveling algorithm that it's doing, it only taps the bed once. So printing this Benchy, I don't know if you guys can hear that, but this printer is quite a bit noisier than this one. And this one has that giant fan back on the side there as well with this duct. So you need the glass. So look at all this fingerprints on the glass. You need the glass to really be able to deaden the sound of the fans inside there. I mean, it does cut a lot of the noise out. So the mass of the glass definitely has superior sound absorbing qualities. Is it worth the extra money? Probably not. This is the budget version of that printer, and well, this is part of the reason. Oh look, the Benchy is peeling up off the bed. You see it in that corner? I gotta stop this print and put some bed adhesive down. I don't know. Treat it like a marker. This applicator is new to me. I've never used Magigoob. I don't know. I guess I should have experimented with more bed adhesives, but this stuff has worked for me, so I've never found a reason to try anything else. Let's pull this Benchy off the bed and compare it. Here, we'll just leave that string on there. We know that that's the one that came off the Flashforge. So this one here with the broken chimney, because my 6-year-old kiddo was playing with it, this one came off of the Bambu Lab. And I had a little goober left on the nozzle, so ignore that little imperfection there. Let's see if we can see much of a difference between these two. Now keep in mind, I didn't slice either of these. This is the G-code that came on that printer, and this is the G-code that came on this printer. Yeah, the bow looks about the same. Actually, that little layer shift. Now what's going on there is there's it's going to be, that's where the deck here starts inside, so that's where the cooling is going to change, because we're going to get into the thin bow section. So there's going to be, you know, support material and whatnot. So that's why you're seeing that sort of layer shift here, and you're not seeing it on this one. This might have printed more slowly, and that's why I'm not seeing that single big layer shift. But other than that, the part cooling, see the arches, they look the same. There's no ringing on either one of these, so the calibration with the accelerometer, you know, the vibration calibration, the ringing calibration is working flawlessly on both these printers. I literally can't tell a difference, you guys. These are, I'm getting the exact same quality. So let's compare with the Easy 3'd K9, and you're gonna see a little bit of drooping. See across the top of the window there? So the part cooling isn't as good with the Easy 3'd. Now a Benchy does not tell the entire story, and this print took like 3 hours, I think, on the Easy 3'd, and this took like, what, 20 minutes or something like that here on this Flashforge. So yeah, much more desirable. But at $500, it's more than 5 times the price. So you got to ask yourself, what are you trying to accomplish with a 3D printer? And judging by the success of my last video, what you guys are trying to accomplish is the building of functional prints such as this 95% 3D printed folding Glock 17 toy here. Squeeze the trigger, the whole thing works. It ejects shells, last round hold open, the whole 9 yards. But this slide has a problem because I had to drill it out. You see that large hole there? I got the CAD model wrong when I made this. So let's see if we can print a new slide for this that doesn't have such a ridiculous hole there where the firing pin sticks out. Here in my CAD platform of choice, that being Rhinoceros 3D, we can see the slide as we're going to print it, as well as the support material. This is like customized support material that I've drawn in there. So we need to get this geometry into the slicer. And I'm using Orca Slicer, which is probably the best option for this printer. I think it's the one that they kind of intend for you to use. And Orca Slicer is a slightly different version of, what is it? Bambu Studio,
which is an updated version of Prusa Slicer, which is an updated version of Slick 3R. So Alessandro something or other, Ranucci, I think is his last name. He's the guy who invented that slicer. So all this is built on just his hard work. That guy, he's like now occupying a position in the Italian government as the head of open source or something crazy like that. He's well tied into the Arduino project, and yeah, just a big power player, and we have him to thank for laying the foundation that has become the sort of slicer wars that we're in. Anyway, yeah, Orca Slicer is a great one, so let's go with it. And Orca Slicer just recently has had the ability to connect via Wi-Fi to printers such as this one, the Flashforge Adventurer M Pro. You can see I've already got the printer selected here, and if I click there, what I did was I select printer and it's on the list or whatever, and then after that's done, you click on this little Wi-Fi thing. The first thing you have to do is select Flashforge as your host type, and then you can enter in the IP address. You go right here to information, then you click this little icon right there, which is your Wi-Fi icon, and you click on Wi-Fi. Takes a minute. It is slow. There we go. Now I can select my network and enter in the password. Then just wait for it to connect. Then from the home screen, you click this little icon and it provides your IP address. And then everything should be working. You should be able to connect via Wi-Fi. You can come up here, and if you want to print to export G-code, that's to put it on a thumb drive. So you could take the thumb drive and walk it across the room if you really want to be secure with your network and not have anybody see your data or something like that. Or if something's going wrong with your Wi-Fi and you still want to be able to 3D print, you can just use a thumb drive like that. But since it's already selected to print, we can just click that, and this dialog box comes up, and then we can just click upload or upload and print. If you click upload, it will just appear on the printer, and you got to walk across the room and click print on the screen. Or if you do this, it will automatically start from across the room. So very clean. And this is printing over LAN, local area network, which we need to talk about. Because Bambu Lab here is setting the stage. They're setting the bar that everybody else needs to clear as far as Wi-Fi printing goes. Now, I have previously used a DIY control board called Duet, which had a LAN functionality, which was fantastic. Not only could you send prints and do all this kind of stuff, you could also mess with the firmware. You could adjust settings and stuff like that through the LAN at your computer. Fantastic stuff. Now, Bambu Lab's not going to let you get into the back end and mess with the firmware. No, they're really sort of obeying the Apple design idea as far as it relates to treating their customers. They'll take care of it all, and it will just work. But that means that they have control over a lot of stuff that you should have control over. So if you're against software as a subscription, bad. You know, Apple is not great. They, Adobe, really not great, right? But these companies that are trying to just make it all work so easy for you are basically gonna have control. The more you let them do, the more control they have over you. So that is why I actually prefer this one, and I like this one a whole lot better. Now you can print through the LAN, the local area network, on the Bambu Lab. I've never done it. I've always walked across the room and popped out the little micro SD card. Let's see if I can get it here without looking at it. It's this tiny little slot. It's really hard to get. You got to have your fingernail on it. Come on. There we go. Got it. This is left-handed too. So, tiny little me thing, trying to get it back in there. Walking that across. It's fragile. I might break that someday, right? So I'm not gonna push it in all the way. Versus the USB stick on this printer. So much better. I like that so much better. And I also like better the fact that this doesn't quite have as much polish on it as far as the printing over Wi-Fi goes. So this is only print over LAN, whereas these guys want you to print through their server farm. Now there's reasons for that. Because you're printing through a server farm, you're able to send a print from your PC and then keep an eye on that print from your phone. So you could go back in the house, or if you're working out in your garage or something, and then, let's check on my print on your phone. Oh no, something's gone wrong. You can cancel it right from your phone. That's kind of cool, but it involves going through their servers, which they control, and they could send an update to that firmware, which locks you out of that printer. It's always connected to their servers, so anytime they want to do something, or hey, let's say that China gets more control here in America, and you start to want to print
something that the totalitarian government doesn't want you to have. They can recognize objects like this, machine learning, and they'll just shut you out. Not that these guys aren't, because they're going through the LAN as well, so maybe it's possible here as well, but the fact that this company doesn't have their stuff together quite as much, it's a little bit, they're not doing their own slicer, right? They're not running a server farm. They're just letting you do local area network connection to Wi-Fi print. That makes me trust them more. I just don't think that they are sophisticated enough to really seize control, and I am forced to control the ecosystem a little bit more myself. And I think that's the better way to go. So as far as the Wi-Fi printing goes, I like this one because it's worse, if that makes any sense at all. All right, let's see how the new slide for this thing is going to turn out. And this is what you get, I guess. My support, I drew that into the CAD file itself. Looks like it came off, but maybe we still have a functional print printed at 45 degrees. So potentially, yeah, it looks like it worked. I'll check that out. All right, so we got a new slide for my toy Glock. All the metal parts, the upper parts, get installed into this 3D printed slide without any issue. And the 3D printed barrel as well is going on there quite nicely. So this does look to be a fully functional print coming off of this printer. It's getting my stamp of approval. I don't see any issues with this slide that I can blame on the printer. I am using some old filament, which isn't completely dry. I was getting some wispies, and for that reason, it will install onto the slide, or onto the frame, and you can see this little, that clicks into place. So it's on there now, but when I try to cycle it, the design has a little bit of a clearance issue here, and there's also a little bit of tightness in the grooves which interface with the metal rails. So I can't blame that issue on the printer. That's going to be my design and the filament combination. Also 0.2 millimeter layer lines here versus 0.12 millimeter layer lines on the frame. So yeah, I'm going to say thumbs up. This definitely makes dimensionally accurate parts, and it's as good as that one over there. Let's do a boat race between these two printers. I've got both printers at 200 degrees on the nozzle, 35 degrees on the bed, and we're just going to start it here. I don't know what temperature it's going to want to get to, but let's get this race going. All right, on your mark, get set, go. Yeah, this one definitely starts printing faster, like it's already going. In fairness, this one over here might be gonna poop out some material. It does that purge thing because this has the AMS system which can go along with it. So standard operating procedures, maybe, but you know, if you're making your printer so fast as far as the functionality goes, you could make the startup routine take a little less time as well. So that one is now leveling the bed. You know, this one didn't do any bed leveling. It just went right to printing, remembering the old leveling algorithm. And finally, that one is spitting out plastic. Maybe? Sweeping XY mech mode. Oh, so it's doing the, why would it do, you know, in a speedboat challenge, why would it do the compensation for the vibrations? So it's doing all this vibration stuff, but look at all that schmoo coming out of the nozzle. I gotta clean that off. All right, now it's laying down some filament, finally. Now it's doing the complete calibration. So it's gonna do the laser scan and everything. Meanwhile, this printer is laying the deck. Already done with the hull, and it's starting to lay the deck on the Benchy. There we go, now we're printing. Then it does this check here, inspecting the first layer. That's a pretty fancy thing that it does to make sure that you don't have a spaghetti mess, and it does get a good first layer down. All right, the Bambu Lab X1C is putting, you know, the second layer on the deck there, and over here the Flashforge is almost to the roof, printing the top of the window frames as we speak. Credit to the Bambu Lab, it's really catching up. That is moving quite a bit faster now, and almost done over here, but that bamboo is close on the heels, even having done all that crazy setup algorithm. So I'm gonna turn the camera off so that I can start a stopwatch and see just how much longer it takes for the Bambu Lab to finish that print after this one gets done.
9 minutes. It took exactly 9 minutes longer to finish this print on the Bambu Lab X1C. Do a print quality comparison. We've already done this, but you know, can't tell the difference. You guys can look, but there's literally, it's indiscernible, the quality difference between these two. And so the Flashforge was faster just because it didn't take so much time to start printing. So the Flashforge is reporting that it took 14 minutes to do the print, and the Bambu Lab is reporting 24 minutes, which would be a difference of 10 minutes, and I only measured 9-minute difference. So somewhere between these two printers, somebody's not giving an accurate number. All right, I just unloaded some of this filament here. The process for unloading involves just clicking the load button with no filament, you know, following what's there, and then it just purges the nozzle and you're good to go. So if you click right here on this little PLA button, it allows you to select other filament types, and I'm seeing, you know, carbon fiber PET G, polycarbonate PA for nylon. So we've got all the filament types supposedly available, and what's interesting is carbon fiber. So I wonder if there's a hardened nozzle that came in the kit. The answer to my question, here in my hand, the 0.4 millimeter nozzle that came installed in the printer, you can see the tail of the filament there, is chrome. That's the, you know, the sort of silverish coating to that nozzle, but the 0.6 millimeter nozzle that came in the box is blackened, and that's the telltale sign of hardened steel. Yeah, so I don't know what they're doing here. There's not a lot of documentation. All I can really find is that one of these replacement nozzles, just that here, costs $35, and it doesn't show that you can get just the nozzle. Yeah, this hot end, it looks pretty cool because it's very contained, and it's you know, toolless swappability. We'll get to that in a minute, but I don't like the fact that it's encased in plastic. This would be PEEK plastic, high temperature, very, very high temperature plastic, and that's going to have a 280-degree maximum temperature on this printer because of the plastic. I haven't seen plastic hot ends since the GE Tech hot ends from, like, I don't know, 2015, 2016, something like that, and those were notoriously so bad that they spawned the E3D as a company, and E3D V6 specifically, you know, which got used on the Prusa, and so China was just messing up so badly with those plastic hot ends. So I don't know why these guys would revisit that failure by encasing the part that gets the hottest on the whole printer in plastic in a low temperature. Even though it is high temperature plastic, it's still plastic. And the only reason that they're doing this is for ease of, you know, nozzle changeability. No tools involved, just change it out. And that capability, in my judgment, is absolutely not worth the handicapping that is caused by, you know, encasing the whole thing in plastic. Well, here goes $35. Let's disassemble this and figure out just what it's made out of, starting with that the actual nozzle. Getting a good hold on the flats, the plastic just sort of spins around it. So the copper heatsink has these flats on the fins, which is, that's kind of funky. Fins aren't very strong, but hey, copper heatsink, very nice touch. Copper has amazing thermal conductivity, so really good way to strip the heat away. This is called the cold end, and the whole thing is called the hot end, even though that would be the hot end and the cold end. Anyway, let's see if this works. Something's coming apart there. Feels like the heatsink is just coming off the whole deal. That's not what I wanted. The thermal break here between the hot end and the cold end is nicely very small. That's a really great way to prevent thermal, you know, the heat being transferred. It can't even go across that bridge. There's very little material right there, which means it's going to be very fragile, but I'm gonna timidly pinch it here, see if I can get that nozzle out of there. Nope, I just got the thermal break here to unthread, so still haven't been able to get the part that I want out of this assembly, which is the nozzle itself. So you can see there's an insert here. This plastic inserts into that plastic, and the two come together with these little clips, but this PEEK is not very flexible, and so I'm not going to be able to pry that apart. I'm going to have to do some destructive disassembly here by just clipping these tangs off. And that's how you stab yourself with a screwdriver, doing things like this. All right, I got it. We can see all this pretty hardened thermal paste
encasing everything. There's going to be 2 wires going in there. That's these 2 wires right there. Those are the nichrome wires that are going to be wrapped around, looks like a copper, I don't know, heat block, I guess I would call it. It's kind of a tube though. And then with this thermal paste rubbery stuff, we're going to have the nozzle effectively glued into that copper insert. And that's such a bummer. They should have put 2 little flats up here at the top for the copper to grab the copper with. And let's see if I can even get this apart like this. There we go. Got it. That is crazy. Look at that. We got a copper outer threads and just like an acorn nut tip. This is the way that original hot ends, when they were DIY, you literally would take an acorn nut and drill a hole down into it. So this is some very old techniques here for designing hot ends being used, and they are really proprietary. There's nothing industry standard about this. So if any company out there like Slice Engineering is going to design a new hot end, it's going to have to be the entire deal. There's no just replacing a nozzle. That's not going to work. And we can see the filament coming down here, the red filament. I have never run anything through this, so this is just going to be the red filament that they sent in the package, and I'm pulling it out here from the, there we go. So that's gone through the melt zone, they call it, which is going to be from top to bottom there. That's effectively a high flow melt zone. So that's like a mosquito, or no, like a mosquito. What's that E3D product called? A volcano. That's like a volcano hot end, maybe even just a little bit taller, and all copper. So this is going to be better flow than a volcano, but we're not going to get that CHT split nozzle capability where there's like a divider right there in the flow path for the filament to go through. So the high flow is not going to be as good as it could be, but pretty decent. And look at that. I've crushed it. I can't get this threaded in there anymore. So I have destroyed. Bummer. I should have been grabbing that with this threaded into it. Ah, what a mistake. All right, I've been squeezing on this thing, getting it somewhat round again, and trying to thread this back in there. It almost catches, but you know, I compressed it on all sides, so I've shrunken that down. I need to chase those threads, and this is the thread pitch. I can tell because these teeth line up nicely. So we got a 0.5 millimeter metric thread pitch, but it's 3.89 millimeters on the outside diameter there, which is a strange size. I mean, it could be, I guess, 4 by 0.5, which is a very strange tap size. I don't have that, and kind of proprietary. So they really, really don't want you to mess with this unit. They really want you stuck in their ecosystem. There's lots of room for improvement, and there's no ability for anybody to DIY another solution. So another company is going to have to step up and create the good options. So disassembling and playing with this nozzle has taught me what the weird T-pin tool is for. It's for clearing jams in the nozzle. So get it up to temperature, shove that needle right on through there, and hopefully anything that you have that's problematic can come right out. But hey, $35. And so if you get a really stubborn clog in that nozzle that won't come out, you won't be, you know, this isn't going to fix it. So you're going to have to pay $35. So yeah, this is the worst thing about the printer that I've seen so far. So let's go looking for more things that are wrong with this printer. Now, the, you know, plastic doors that I lamented earlier aren't so bad. And the reason that they're not bad is because they fully seal. We have this foam all the way around the opening, even back here. So we get a good soundproof seal at the top and here at the front, which is more than I can say for the Bambu Lab X1C, because this rubbery seal here it stops right there, and that's all plastic. Down here it's all plastic. So we have 3/4 of this door which does not seal, even though it's made of glass, and that allows more sound to come through, but it also means there's an air gap there, so it's not a very well sealed print chamber for getting the ambient air inside here up to a higher temperature, which is better for higher quality printing. Because the door here at the front is all made out of plastic, we're not gonna break it. We can slam that thing open all we want. It's gonna be plenty flexible. The bed here is pretty nice, you guys. It's got this, this great thick handle. It's got two sides with this textured print surface. We saw earlier that we do need to use the glue on it. Look at, here's the purging, sort of just lays a purge line there. And I like it. Flexible, so you can flex your prints off of it. Works quite well. These corner catch pieces receive the corners of the bed, so you can't really get it in there crooked. That is far superior to the Bambu Lab. However, the printable area on the Flashforge bed is smaller, as illustrated by these detachable print surfaces. But the interesting thing about that is that the aluminum here, that's the actual sort of sub bed, the main heated, you know, sort of a heat sink for the PCB. You can just see that the PCB is printed on the bottom side. So this bed here, the aluminum goes edge to edge. So that is the same, probably the exact same print bed as on the Bambu Lab. But with the Bambu Lab, they're cheating and they're sort of blowing over the edges like so. They're giving a little bit of extra with the print surface. But those very edges on the Bambu Lab are not heated, whereas edge to edge here on the Flashforge is heated. Also, the fact that you can kind of get up under there if you need to. You know, I've seen thermistors go bad before, so that's much more easy to fix in the very unlikely case that happens to you. Usually thermistors go bad because of user error, so if you just don't touch it, probably won't break. And also, while we're in here, we can see that Flashforge is using the same technique as the Bambu Lab, and that is to have a piezo, it's kind of like a microphone. So we have a piezo sensor at all four corners, and so it registers sort of the sound, the vibrations. So as the nozzle comes through and taps, those piezo sensors go, yep, I'm feeling it right here. I'm hearing it, basically. And so that's how the printer knows when the nozzle is touching the bed. And because the actual nozzle is the thing touching the bed, you're going to get the most accurate first layer that you can get. You're not going to have some sort of like a nozzle offset weirdness to deal with, any of that. Although there is a nozzle offset in the firmware, which I've seen videos by TH3D that show that can be problematic. So if you experience that problem, go look for the TH3D fix video. It's out there. What is this? VOC, like volatile organic compounds right next to the filter? Yeah, I think that's what that is, a sensor for the VOCs. So when the firmware detects a high, count of VOCs, then it turns the filtration on. And so you're not sort of, I guess, wasting the filtration the rest of the time. Instead of just having it on permanently, they're turning it on as needed. Let's take a look at this filter back in here. Now there's two of them, right? We got one above the bed and one below the bed at the moment. And yeah, they look to be identical. So let's just take one of them out. Pulling the ribbon here. So I've torn the top of this filter apart so we can see what's going on here. We've got the microparticulates, just a size, filtering for size here at the front. And that's what this sort of fuzzy fiberglass, I don't know what that is. But yeah, it's going to filter for particulate sizes. And that's nice because, I'm no expert in this, but from everything I've read, in all these years being involved in 3D printing, the main health hazard is microparticulates. So just little tiny, globules of plastic that get airborne. So this nozzle is basically sort of spittle. And think about a spray bottle, right? And you're sort of misting the water into the air from a squirt gun spray bottle kind of deal. Well, that nozzle is doing something similar to plastics. And so you get these little tiny, dust particles of plastics floating around. And so I think we need a scientist to, somebody to really do the science on this to weigh in. But I think that having that micron filter mesh at the front is much, much better than the solution Bambu Lab is coming up with, and that is just to have the pure adsorption filter here. So those are going to be little like carbon granules that you can see down there in that little hole. It's basically just going to be activated carbon, which can chemically bond to volatile organic compounds, VOCs. And you get VOCs, but mostly you get microparticulates. So yeah, we have a two-stage filter here, and we have two of them, upper and lower, and we have a sealed print chamber. So absolutely, bar none, far and away the best 3D printer I've ever seen as far as air quality goes. Hallelujah, it's about time. This is awesome. For part cooling, we've got this large nozzle here that blows across at the height of the print nozzle. So even though the bed is way down here, as the print is printing, where the filament is being deposited is always on this plane. So that is a large sweeping thing. And the Hevort YouTube channel is the guy who came up with this technique. He has one on both sides, but there's only a single-sided one here, so they're just copying Bambu Lab with that. But Hevort is the guy, smart guy who came up with that idea. So it's an awesome thing. The front of the whole print carriage comes off magnetically, just like Bambu Lab, and just like Bambu Lab, we have sort of an offset split part cooling deal, which is going to make sort of a vortex around the nozzle. The motion rods for the X-axis are made out of steel, so those are not going to wear. They're going to be a lot heavier, but they're not going to wear compared to the Bambu Lab X1C. My magnet here is sticking to the bent steel subframe that we've got on all corners and across all the tops. So all the structure here being provided by steel, which is nice. And I'll display this animation from the website, but basically all of the panels are sort of bolted from the outside onto the steel structural system. It's the little things, you guys. This is the thickest sheet metal that I've seen on a cover plate for any Chinese 3D printer that I've ever had in my hands. So they're clearly not skimping on materials, which is awesome. It's good to see. Control board here, I'm 100% sure that is going to be a 32-bit processor if we get a close look at it. Judging by the sound of the printer as it's operating, these are going to be trinamic stepper motor drivers because they are quite quiet. And the best thing that I'm seeing about this back end of the printer is it's completely walled off from the actual print chamber. It's not insulated, but it is walled off, and that is a major, major step. So that means that the electronics and everything happening back here will not be negatively affected as far as longevity goes by being heated up because it's close to the hot bed and the hot nozzle and all that. So fantastic. Really, really great thing to see. Definitely a step forward compared to the Bambu Lab. And to accomplish that, you've got this duct right here. So that's on the other side, inside of the chamber, that's where the air comes in and out. And this vents to the outdoors. Back there is the fan for the upper filter, and down there is the fan for the lower filter. So the filters share a little bit of air with this chamber through this fan, but it's not too bad because that fan gets to vent right through those circular holes right there in the bottom corner. So we're really going to be limiting the heat that gets back here, and that is a good thing to see. We've got this CZCL branded power supply, so like a network plug for plugging your Cat5 cable into, and that way you don't have to use Wi-Fi and make your printer vulnerable to some attacks, like maybe the guy in the apartment next door to you sees your printer on the network and tries to hack it or something. But if you plug in, also if you've got a print farm going, you can plug a bunch of them and get really high throughput, I guess, through good data, and have like have a single computer controlling a bunch of printers, and they could not be connected to the Wi-Fi at all, so you could have a firewalled printer network for lots of security. Full-sized NEMA 17 stepper motors for the X and the Y up here. You can see we get a little bit of a wraparound going there as far as the belt routing, and similar situation there. Down at the bottom there's the Z stepper motor. Again, all three of these stepper motors are part of the electronics that are isolated on this side of the firewall, thus making the very harsh environment inside the printer not putting undue wear and tear onto your electronics. You guys, I'm seeing so many great solutions to the issues that I raised in the Bambu Lab X1C video. I wonder if they watched my video and used all of my criticisms as a checklist, because they really have addressed so many of the problems, and I'm impressed. I'm impressed, you guys. This is a solid printer. Really, really well done. Looking underneath the printer, we can see the 1, 2, 3 lead screws all being driven by a single stepper motor. We saw that inside the electronics compartment. And there is the belt tensioner, and that's how that system works. Once again, if we're being totally fancy, which this isn't supposed to be, this is just a solid performer. But if we wanted just that like utmost tool, we would isolate all three of those lead screws so that the bed could be physically leveled, not just sort of software compensation. But you know, hey, this is fine. $500 printer. This is awesome. This is great. Totally functional. The movement carriage front cover attachment is superior to Bambu Lab because it's got these two little tabs that sort of physically hold it, as well as the magnets down below that keep it from flopping off. So that's a much better, more solid connection like that. Disassembling the movement carriage here, I'm noticing that there's some clever injection molded pieces that sort of jigsaw puzzle together back here to make this whole carriage. It's quite solid because of their construction method. And I know how difficult it is to engineer injection molded plastic parts like this. So very, very well done. But this is sort of a heated chamber, right? So how temperature resistant is that, that plastic? We want to put glass fiber reinforced GFRP plastic or even carbon fiber reinforced. So the additive to the plastic keeps it from deforming in the heat, and it makes it stiffer, which we kind of want here on a movement carriage. Let's just check and see if we can hear if this plastic has glass fibers in it. No, that's smooth as butter, you guys. There's no glass in there. What I'm also noticing from this viewpoint is the extruder stepper motor here sitting right in the middle where all these belts come in, and the belts are fastened out here at the edges. So they have no excuse for putting these belts so far apart. They should have been stacked one on top of the other as close together as possible to prevent any racking, any twisting of the movement carriage here. Here we can get a view of how the toolless, two-handed nozzle changing system works. These are just going to be lever arms that are spring-loaded, and this little catch right here grabs the side of the nozzle on both sides. Removing this plate from the back of the movement carriage, we can see that the linear motion rod bearing is just constrained within the injection molded plastic, and it's held tensioned even with this plate because you see that movement. So if you guys will remember from the Bambu Lab, there was a spring on this bearing, and that would keep it from sort of clicking, click, click, click. It sort of added a little tension, pre-tensioned the whole system. So I'm guessing that they've got such a little bit of tolerance issue, so that everything is so tight with this printer that the plate here is acting like a spring. I think that must be their solution here, because I didn't notice any play before I took this off. So this whole movement carriage hot end assembly here is pretty intricate, but it's not that hard to take apart. So if maintenance is required, there's nothing too tricky about it. We've got this 3-part mold. So there's a clamshell from the top and the bottom, and then there's like the whole slide that slides into this chamber here to get this part molded. Looks like a simple box, but it's quite challenging. Yeah, the mold to make this part, deceptively simple as it looks, the mold is quite intense. It's got features from this side. It's got a slide that goes into here. It's got a slide that goes in to get this grate, a slide that goes in to get it from this side, and a slide that comes up from the bottom. So this right here, oh yeah, and it's got a slide from the top. So literally, this has to come apart on all sides of the cube. Crazy, crazy. That's very intricate. And then this extruder assembly, also pretty intricate, bolts in there. Let's take a look at the extruder. This is as deep as it goes with the extruder. So if you have any problems, like let's say you wear out the teeth on this gear because that's a metal gear coming off the extruder, well, you'll have to buy a whole new extruder unit from Flashforge. The seam here, you can see right at my thumbnail, has been ultrasonically welded together. That's a really cool process. Look that up if you don't know what that is. But that's going to be impossible to break that apart at that seam, at that construction seam. So yeah, this is a whole unit in and of itself. You can see the screw right there for adjusting the tension, feeding this little length of filament up inside there. And then scratching it with my thumbnail, I can feel the grip where the extruder was grabbing onto it, and it does come from both sides. So that's going to be a dual hob gear extruder. And looking at just how close this axle is to the center line on the filament path, those are going to be some pretty small sort of filament feeding grip wheels, call them hobbed gears, that's the typical nomenclature. We've found recently with Western designed hot ends, such as the ones coming from Bondtech, most notably they pioneered it and then Prusa sort of copied it. But the larger the feeding wheel, the better, because the pulsations, the cogging of your stepper motor here, because your stepper motor has, it can spin sort of infinitely, but in between there's sort of indexes, as it's spinning, where it's stronger. It wants to be here or it wants to be there. And so it can go in between, but it's weaker in between. And because it's having to push on this filament, that manifests on the print. So having a larger feeding gear, the hobbed gear, has benefits. So yeah, well, that is what it is. I guess some company, if this printer became really popular, some company could definitely improve on the hot end extruder combination. Slice Engineering, Bondtech, I'm looking at you. And if you find yourself having to disassemble the hot end, know that all you need to do is take off this cover at the top, and then the 4 bolts from the back right beside the linear motion bearings, and then this whole unit will pop off. And it's easier to deal with here on the table like this. Taking my little jeweler's file here to this shiny metal hot end, I get good bite on it, so there's not a chance this is hardened. There's a chance this is stainless steel, which is a terrible material choice, but hey, that's plastic, also a terrible material choice. But I do want to correct the error from earlier. That is brass. You can see the color difference between the copper heatsink and the brass tube there. So this is going to be a little tougher for feeding, abrasive materials such as carbon fiber materials through it. It's going to last a lot longer than it would last if it was made out of copper. And that's the writing on the stepper motor. It's not an LDO, but it looks to be high quality just the same. So getting the movement carriage here reassembled and taking a closer look at the electronics control board on it, it says that it is the extruder control board, but it's also controlling the hot end, the thermistor. It's going to have the thermistor logic on there, as well as all these wires, all the black wires, which are needed to carry all the current to the heating element here on the nozzle. But do you guys see something missing? Where is filament runout detection? It's not here where the wire plugs into the movement carriage, but notice this bundle of wires in this nice round sheath. Taking a look at the electronics compartment of the printer again, we see that same bundle going down over here and plugging into the control board. But right beside it is this little triple wire bundle, and that is the classic sensor or switch bundle of wires. If we follow that down here, it's labeled silk. I don't know why they'd label that silk. Kind of strange. You guys hear that? That's a switch being pushed aside as I slide the filament into the reverse Bowden tube. So it sits about that far up in there. There's a switch somewhere right under there. It's a little bit problematic because I can't even figure out how to get to that switch. This case here is really well, the fasteners are hidden and it's got no movement, so it's not like I can just pop it off. And if that's a switch, well, switches fail. That's what they do. So I don't know. That's going to be a very challenging thing to replace, is what it looks like. So hopefully, fingers crossed, knock on wood, that will never fail. All right, I've got my spray bottle here with a mixture of denatured alcohol and baby powder in it. So I spray something down, and when the alcohol quickly evaporates, it leaves behind the baby powder. You can see I can get it on my finger there. So once that surface is nice and matte, it's not shiny and black anymore, the scanner can read it. This is my $12,000 scanner. I bought this for reasons that I haven't used it for yet. So this is only the second project that I've ever done with it, and I've had the thing for like 6 months. So money well spent, but let's get some use out of it. There's the scan on the laptop. Let's pull that off the laptop as basically an STL, a bunch of triangles, get it onto my CAD program on the PC so I can get good fitment on this upgrade. The best way to make sense of the STL scan is to view it here in my CAD platform in the rendered mode, and you can see just how crusty it gets there at the edges of the scan, but I don't care. I'm focusing right on this corner. That's my jam right there. See, it's really hard to make sense looking at all these triangles in the STL. Anyway, referencing that scan, I was able to make this geometry with typical surfaces that you'll see in a CAD platform. And after coming up with the model for the printer, I was able to create this geometry.
This is going to print quite well, I can already tell, but I need to add some extra support material right along here. So that's the support material, and then you left click and then just add some in there like that. Look at those gorgeous tree supports. I absolutely love tree supports in Orca Slicer and Bambu Studio and Prusa Slicer and Super Slicer. All of these are forks of each other, right? And whoever figured out this tree support in those programs is just, you get my accolades. Just so good. But I want to block the support material right here. If we right click here, and now we don't have a tree there. The rolling pin here, which will hold the spool, has these little cylinders poking out of the end, which will be nested inside of the bearing. And I'm kind of worried that this joint is going to be a stress riser that will break. So I'm exporting the rolling pin as its own STL, but I also have these two blocks. The rolling pin is its own file and the blocks are their own file, but they're imported together. Right click the blocks and change type to be modifier. So I changed the wall count to 5 for that little area there around the joint, and I also increased the infill to 100%. So it should be plenty strong now.
The printer is just about done printing its own upgrade. I love 3D printers, they're so cool. Taking this thing out of the printer, we can see the support material, the tree supports turned out perfect. And yeah, this looks like a very successful print. Popping it off the back side of the board here because, you guys, I forgot to home and do a mesh bed calibration after I disassembled the bed for you all. And so the nozzle was gouging for a test print. It gouged all the way through the print surface here to the metal substrate. So this is the side I have to use now. Support material just pops right off, easy peasy. Kind of cool looking too, like some Balboa or Bibeloa or whatever those trees are called on Madagascar. This one's a little more challenging. Remember, I was talking about using these flush cutters to help me remove support material. Do you guys know how you can tell a blind man at a nudist colony? It's not hard. Just like removing support from prints made on modern printers using modern slicing software. So I've got that screw removed, and now I should be able to just slide this thing in place and reinstall the screw. This print gets a bearing slid onto each end, and then it goes. So we can now access everything from the front of the printer. We can reach behind, install the filament into the Bowden tube back here, and then install the filament spool onto this side-mounted spool holder that is quite friction-free. And the top lid still works without any issues. And after this kind of minimal amount of test printing that I've done for this video, I'm noticing that the lid is pretty scratched up. You guys can see that if the light hits off of it. It's definitely clouded when you're trying to look through it to see your prints. And that's just going to be caused by the Bowden tube here rubbing on the polycarbonate window. It's been more than an hour that you've been listening to me talk about this pretty great printer and watching me upgrade it. So we're going to end it here. A few notes before we go. First of all, yeah, I got this printer given to me by the company. I'm not getting any money from them. I was free to say whatever I wanted to say about it, and they provided me with a purchase link. You can follow that in the description down below, but I don't get any money from that. If you want to support me, do all the good things here on YouTube, and you probably want to get your hands on that upgrade. So Patreon supporters get access to all of the files that I make for these printers and these videos. I've been doing this for like 6 years, 7 years now. So that's how that works. Go become a $5 Patreon supporter, and you can get those files and print it up yourself. Thank you so much for watching. See you in the next video. Have a great day. Bye.
I'm the YouTube algorithm. You should subscribe to Design Prototype Test, ring the all bell and become a fiscal supporter by clicking on the links. As your benevolent overlord, I'm telling you that it will make your life better. Rather than allowing me to keep force-feeding you mass audience, vacuous content, you'll actually be shown the interesting stuff that most people miss.